Welcome to this KontinuumLAB MIDI instrument tutorial and build video. Today we're making the KLIK MIDI Ocarina. I'll show you how to make 3 different versions, starting with very simple recycled materials and up to 3D printing. We'll get into all the details, silly mistakes included, so you can learn with me. Even if you don't have the KontinuumLAB Instrument Kit, you should be able to make this instrument anyway. You'll just have to source some stuff yourself and download the code from the link in the description. But of course, if you do have the kit, then you already have all of the electronics and sensor materials that you need, plus the microcontroller with the code already on it for this instrument and a bunch more. Go get your KLIK right now over at KontinuumLAB.com. Okay, enough about that, let's get building.
Okay, let's get into it. As you can see, the materials here for the very first build are pretty basic. And I split them up into 3 sections here. As you can see, the middle ones are the stuff that comes with the kit. On your left, then we have the tools that we'll need, and then over on the right is the materials that you will need to supply. I always forget something here because I still haven't built the instrument at this point. So, for example, in this case, I forgot the food-grade plastic, which we'll need for the breath sensor. So, just to make sure we have everything, let me just put the complete list of materials up on screen right now. Cool. So as far as the tools, it's really basic here. The most notable thing, I guess, is that there's no soldering iron. We're dealing with very simple techniques today. Excellent. Let's start with the materials that come with the kit. First, we can assemble the breakout board, put the TNC microcontroller in there. Next, the button module with the double cable there, and then the CNY70 sensor module for the breath sensor, and that has this triple cable, this one here, plug that in. Next we'll prepare the key sensors, and that's really simple. We're going to take some of these loose DuPont cables and plug them directly onto these thumbtacks. Okay. Finally, we have the jumpers, which are meant to select options and settings and the instrument and that. We'll get back to those in a little bit. Okay, the cardboard for the main structure of the instrument. Let's see, I've already drawn a pattern on here. Have a closer look at that. The dotted lines are meant to be folded. The fully drawn lines are meant to be cut. So let's just cut those lines. Notice that these lines are spaced using the structure of the cardboard itself. I didn't measure these by centimeters or whatever. That means that these dotted lines are all in spaces in between the corrugation, which means that I can crush one side of the cardboard like this using a pencil or just your finger, and then I'll be able to fold along those lines very easily. And that's going to allow me to make this square shape here. That's going to be the mouthpiece. It is the size and shape that it is because it fits the breath sensor very well. Now for the rest of the structure, this folds just in the same way and it forms the main body. This is shaped the way that it is so that we can fit all the components inside, namely the breakout board. So that's even a little bit oversized, but that's fine. Let's glue the breakout board into place just so it doesn't fall out. Okay, so we can use some rubber bands to hold this together. Keep in mind this is the first and most simple prototype, so we don't really worry too much about those details. Okay, now for the keys. As you can see, I use my fingers to just suss out where I want those keys to be, and then I just make some holes in the cardboard. Making holes in cardboard is very easy. Use a pencil, use whatever you have on hand. Next we can pull the DuPont cables with the thumbtacks right through there. These are going to be the keys, of course. And as you can see, they fit very nicely and they're quite easy to put through there. That looks good. Now let's try to fold this up and see if we can fit everything together. It's a bit of a tight fit, but that should work just fine. Now I used these 10 centimeter cables, which are too short to actually reach the breakout board when everything is unfolded, but once we fold everything up, it's going to work just fine. Also, having shorter cables means less of a mess inside the instrument, less possible sources of noise. So now I am numbering the keys 1, 2, 3, and 4, and let me just put the graphics up on screen right now so you can see exactly where those plug in. The strip of triple pins that go down the side of the breakout board here are used both for analog sensors and for capacitive sensors. The sensor pin is the middle one, and so that's the one we use for the capacitive sensors, as you can see here. Okay, so now that the cables are plugged in, we can still fit everything together. It's a bit of a mess, but it works. Next, we'll move on to the breath sensor. Now, the KontinuumLAB Instrument Kit comes with several breath sensors that are 3D printed and very easy to use, but you can also put one together by yourself, just using the CNY70 sensor module and some basic parts. So I'm going to put the sensor up here on this fold with the cable running inwards. You can see how that goes there. So that's going to be measuring at all times the distance to this balloon here, and we're going to be inflating the balloon using the silicone tube, and that's what's going to allow us to measure how much air we're putting into that balloon. As you can see, that inflates and deflates very nicely. Okay, that's probably a bit too much. So the balloon part is going to go on this section here, opposite from the CNY70 sensor module. This section is about 2.5 centimeters wide, roughly. And so we're going to cut out a piece of the food grade plastic, here it is, of that size. And you'll see why in a second. So let's just cut out a circular disc. This doesn't need to be super beautiful and perfect, but it does need to be the right width to fit into the section that I just showed you before on the cardboard. So what we do with this is we fold it down the middle, and then that's going to allow us to put it inside the balloon. I recommend using a bit of saliva to just lubricate this. Put the plastic inside the balloon and then unfold it again. And then you can see that now this disc is able to be clamped underneath the edges of the cardboard here, so that's why it needed to be that exact size. Now if your cardboard is a little bit bigger, a little bit smaller, then make your disc a little bit bigger or a little bit smaller. The plastic disc inside the balloon is also going to help to stabilize everything so that the balloon doesn't move when we're not specifically inflating it. Great, so this is where the balloon goes. Now straight across from that we need to put the sensor. So let's glue that into place, a little bit of hot glue, and then we can just hold that in place until it sets. This is also a good time to check which of the 3 cables is plugged into ground on the sensor module. There's a little G that you can spot there, and that same cable needs to be plugged into the G rail on the breakout board. So that's pretty simple. Now we can fold everything up again, and we're still able to close that nicely. Very good. Now we have to prepare the silicone tube for the breath sensor. So we just need to make a little hole in that, which is going to be the pressure escape hole that will allow us to blow in it and have actual airflow, instead of blowing in it and then having the air come back through the same hole. So that's pretty simple. We just use a pair of scissors to cut a little hole. Important thing here is that this hole be smaller than the actual inner diameter of the tube. So that's maybe a little bit small, but we can always adjust it afterwards. As you can see, this tube is now 6 or 7 centimeters long, and that's just so that we can reach from where the breath sensor is and to outside of the instrument. Next, we're going to try to fix this tube in place a little bit. And to do that, we're cutting this flap. This is the one that the CNY70 sensor is on. We're going to cut a square flap out of that we can then fold down, and that will help us to hold that tube in a fixed position while we play. So let's put in the balloon and tube again. And now you can see the tube is held in a fixed position. Also, the breath hole that we cut before is now outside of the cardboard, which is a good idea because there might be a bit of humidity coming off of that. Okay, next up, this calibration button module. This is very important because, as you've seen, we put all of these sensors together without any precise measurements or anything, so the readings from them may vary quite a lot. I decided to put the sensor on this side position here, where it's going to be out of the way of everything else. So let's mark that position and then just glue the button module into place. Hold that down until it sets, and then we can plug it in to the calibration button position on the breakout board. Again, the cable is a little bit short, but it's not really a big problem once the instrument is folded up, and also it gives us less cables to deal with. Okay, looking pretty good. Now what we need to do is we need to cover up these capacitive key sensors here with a dielectric material. Now that sounds really fancy, but it's really just an insulating material which doesn't allow electricity to conduct between the metal and my fingers when I play. So I'm just using transparent sellotape. This is polypropylene and it works great for this. Also, being transparent, I can see where the keys are at. So rubber band back on there to hold everything together. Balloon back into its place. And that's it, we're basically done. That's the end of the build footage anyway for this first Ocarina prototype. It could be much prettier in many different ways, but that doesn't really matter. We're going for functionality on this first one. So next up we're gonna plug this in and see if everything works, but I feel like there are some details here that me from the past probably didn't think about while he was actually building the instrument, so let's just have a quick look at those.
Okay, first of all, looking at myself mash those cables onto the thumbtacks is just painful. That technique comes with a high risk of either breaking the cable header or impaling your finger on the pointy bit. Both have happened to me. But in the months since I filmed this build, I've used the thumbtacks a lot, especially in the context of my workshops, and I've developed a much more refined technique. The trick is to hold the thumbtack between 3 fingers, like this, and then you grab the cable by the tip, and then you gently push it onto the thumbtack while twisting, like this, side to side. And that's it. No force required really, and it works every time, most of the time. The second thing I want to mention is about the breath sensor. While the other 2 ocarinas in this video use a 3D printed breath sensor, which comes with the complete version of the KontinuumLAB Instrument Kit, there's also another option for a completely DIY breath sensor, namely the fantastic bottle top breath sensor. I'm not going to show you how I make it in this video, but it's pretty simple and it's featured in several other KLIK tutorials, both with and without 3D printed parts. The simplest version is in the KLIK MIDI recorder tutorial, so go check that out. And if it hasn't been published yet, then stay tuned, it's going to be great. I also want to point out that all of the instruments in the KontinuumLAB Instrument Kit have numbers, and you select which one you're making by plugging jumpers into the breakout board. Like this little fellow here. Let's just get up a little bit closer. So these are the selectors. There's mode, instrument, and options for each instrument. Now, when I filmed this build, the Ocarina actually existed in the code as mode 0, instrument 0, so no jumpers were required. But since then, I've included a bare bones breath sensor as instrument 0. So now the Ocarina actually requires a jumper on instrument pin 0 to select a binary number 1. That's instrument number 1. Boom. Put that in there. And that wasn't in the original build, but of course in the instrument it is there now. One final thing, in a second when I start playing it, you'll see that the KLIK Ocarina has 2 octaves. The way I play the second octave is simply by overblowing in the mouthpiece, as this instrument has no actual octave key. And that's all. I promise I won't have as many comments for the other 2 ocarinas. Now let's see if it works, which, spoiler, it does. And then we can get on with the second build. First we calibrate by pressing the calibration button and then activating all of the sensors. And then releasing the button. We can save the calibration by pressing quickly 3 times. Let's see. So even this stupidly simple sensor is pretty sensitive and responsive. Play the octave by overblowing. And of course, just like on a real ocarina, you can play a full scale here. First just the bass scale. The keys are very responsive and very quick. And let's try that over 2 octaves. So of course you can calibrate that to your liking. And of course there's also a full chromatic scale in there. Let's try that. Very nice.
So we're back at the desk. This first ocarina prototype works just great, but let's see if we can't make something a little bit more permanent. So just like before, we have the materials out here, and in the middle we have the stuff that comes with the kit. So most notably, you'll notice that there's no breakout board this time. So instead we're using the TNC microcontroller as is, and we're plugging cables directly into that. So then you will also notice that there's this 3D printed item here. This is the breath sensor, one of the breath sensors that comes with the kit. And this is going to do pretty much the same thing using pretty much the same components as the last breath sensor that we made for the first ocarina. So the CNY70 module fits in there. And to go with this sensor, we're using basically the same materials as last time. A disc made of food grade plastic. And you can see how that fits into the breath sensor there. We'll get back to that in more detail. So then to substitute the cardboard, we have this plastic material here. This is corrugated polypropylene, sometimes called fluted plastic. It's used a lot for science and stuff like that. The cool thing about this is that you can work it pretty much like the cardboard by cutting it in one direction and bending it while maintaining rigidity in other directions. It comes in these large sheets here, and it can just be cut out from there with a Stanley knife or whatever. So it's pretty neat, and it's easy to work with, and it lasts much longer than the cardboard, and it of course resists humidity and stuff like that. Okay, let's start preparing this. Some of the preliminary steps are the same as before. We need to connect the thumbtacks to the cables. So that's the 4 of them. And as you can see, the rest of the cables here are also separate cables, unlike in the last build. And that's because we're plugging them in directly to the microcontroller. So we might need to take the 2 cables, for example, from this calibration button module and split them up to 2 different places on the microcontroller. The same goes for the CNY70 sensor module. And speaking of the CNY70, let's try to put together the breath sensor. So assembly is pretty similar to last time. Balloon has the disc inside, goes onto the tube, but then now we're going to simply fit it onto the 3D printed parts here. As you can see, that's basically the size and shape of that top piece. And then we clamp the other one up against it, insert the CNY70. As you can see, it's now pointing down at the balloon, and then we hold everything together with a rubber band. Pretty simple. And then of course we need to plug in the cables here, and again we need to just keep track of which cable goes into ground so that we'll know where to plug this in on the microcontroller. And that's the whole breath sensor. Now we can move on with the main body of the instrument. So let's get some of our corrugated plastic here. And as you can see, we're going to be making something of a similar size and style to the cardboard version. Here are the measurements, although they don't really matter specifically very much. Again, I'm using the actual corrugation to measure equal sides to this box shape. Again, just like with the cardboard, I'm breaking the corrugation on one side. Make sure you don't cut all the way through, just so that I'm able to fold the material. Now this is great, but now I'm folding it with the cuts on the outside. I really want to fold it the other way, but the material actually gets in the way. So next to each cut that I just made, we're going to make 2 more cuts, one on each side. And we're going to do that for all of the cuts. That's what that looks like. Do that all the way down the material. And then next we're going to actually remove these bits of material, which is going to allow us to fold the material inwards instead. So be careful with your knife while you do this, and just cut it off like that, and now the fold is perfect. We even get this nicely rounded edge, and the material is pretty sturdy. Polypropylene is strong and flexible, so this is going to last for a long time. Like I said, be careful not to cut your fingers. And there we have all of the folds, 4 folds in total, and as you can see, this makes sort of a wobbly box-like shape. And to stabilize that, of course, we're going to use some of our trusty hot glue. And as you can see, I'm using quite a lot of hot glue here in each bend, but even so, as you will see a little bit later, this turns out to not really be very strong. I do have some comments about using this corrugated plastic material in general, and I'll get into that a little bit later. For now, just notice the shape that I'm making here. I'm gluing 3 bends into permanent angles, and then the 4th bend I'm leaving open, and this is going to be what folds the, let's call it lid, to open and close the construction. So now I just hold this steady until it's set, like that. And for now it seems to be quite sturdy. So what I want here is, I want this large piece to go under the small piece so that it'll work like a kind of lip that holds everything together. So I need to just cut a little bit off of that. And as you'll see, I'm going to be cutting off a little bit more later on, just to make it a little bit easier to open and close this. But it actually works pretty okay for now. Let's see if the breath sensor fits inside there. It fits perfectly, so that's nice. Okay, so the next thing I decided to do is to use these little separate end pieces here to close up the box structure completely. Now, honestly, this isn't really necessary. I'm just trying to make things neater, and in that context it's not a very good idea because it doesn't turn out very neat. But this is what I did, and so I'm including it here in the video. You can see that the pieces are just cut into shape so that there's a little extra space underneath the lip, which makes it easier to open and close the lid. And then I just glue it into place with some hot glue. So just to be very clear, this is not a recommendation. I will personally not be using this construction method again, at least not for a box of this shape and size. But even if it is kind of ugly and I don't have anything very nice to say about it right now, it actually still works. And that's kind of my point. These instruments can be made to the level of perfection that you want, even this kind of very non-perfect level. But enough about that, so let's move on. Now we need to figure out where to put the keys. They're going on this top surface here, and as usual I'm just using my fingers to measure where to put each key. I don't really need a ruler. The important thing here is how your fingers naturally fall, the distance between them and their size and so on. Then we need to make some holes big enough to put the DuPont cables through. This pointy object is a little bit too small, so I have this other one to expand the hole a little bit afterwards. That should do it. Yeah, looks like that works just fine. Then we can just pull the cables through. Okay, now to make the individual keys we need some dielectric material. I'm using this electrical tape. And unlike the last build, I'm going to make individual pieces, one to go on each thumbtack. Sorry about the noise. And I'll just trim down the edges a little bit and then fold the edges down underneath the thumbtack. Now, you're never going to get this perfectly round, so I'm just trying to fold it down and make it neat. A pentagonal shape is probably the best result you can hope for, maybe a hexagon. So this is going to give the individual keys a little bit of thickness, which hopefully makes for a nicer tactile surface. As you can see, this is slightly raised off of the instrument surface, so that's going to be much nicer than the previous one. Notice also that I'm gluing each key down to the top surface here, which is because this is meant as a permanent construction, unlike the cardboard instrument, which can be taken apart and put back together in tons of different ways. So let's move on. Now we need to figure out where to put the microcontroller. And I think it's going to go right underneath the little lip here, opposite where the breath sensor goes. So we need to make a hole for the USB cable. Rather than cut a hole which is big enough for the actual USB plug, which is quite large, I'm just making this kind of slot here that I can slide the cable in through.
That will just make it much easier for me to remove and reinsert the microcontroller when I need to, like that. Okay, cool. So let's see. Now we need to make a hole for the breath sensor tube. So I'm going to put that exactly at the opposite corner of where the USB cable comes in. And this hole does need to be the same size as the tube, so that's roughly 8 millimeters in diameter. And the breath sensor is already assembled, so we can just take the tube and slide it through from the inside. And then make sure that everything fits in there nicely. Trying to not bother the key sensor cables too much with the breath sensor, but as far as I can see, this should work fine. Okay, that's what that looks like up close. And now I'm just going to reinsert the microcontroller so that I can see what... oh yeah, so here we go. That's the glue job that didn't really work. Yeah, the thing is with this polypropylene, the hot glue isn't hot enough to melt it. It doesn't do any sort of chemical binding, it's just mechanical force. So what I'm doing now is I'm making some notches into the plastic so that the hot glue will have something to hold on to much better than it does with the clean cut from before. So then we just apply some fresh hot glue and repeat the process from before, but this time it's going to be quite a lot stronger. Okay, so now the glue is set and everything is nice and strong. Then I'll just trim the breath cable down to size and then make that hole, which I forgot to make before, the breath escape hole. Okay, that's probably a little bit too small, but we'll leave it like that for now. Okay, time to put on the calibration button. So I'm going to put that right in the middle of this surface here where the USB cable comes through. I'm just going to cut a little vertical hole, just wide enough for the 2 plugs on the cable to go through. Just like that. And then I'm just going to glue the button down right next to that. So you might have noticed that I use a lot of hot glue for all of these sensor modules. I find that it's really easy if you want to remove them later on to use for something else, to just peel that glue right off the backside. So you might want to do something else, maybe double-sided tape or whatever, but this really works for me and I very much recommend it. Now it's time to number these keys. So key 1, key 2, key 3, and key 4. Just stick with me for a second. This is the numbers that the keys have, and that's just so that we'll be able to play the scales correctly. I'm going to number them on the inside here with the marker 1, 2, 3, and 4, and we're going to use that information to plug these guys into the right place on the microcontroller. Now the way I plugged this in here in the video of the initial build is not exactly how it ended up being done. So let's just cut off the build footage for now, and let's bring up the graphics of exactly what plugs in where. Okay, so once everything is plugged in the right place, we can connect the USB cable again and then just slide everything into place here. And just do one last little inspection to see if everything is more or less in its place, and then we close back up the instrument like that. And there it is, the second Ocarina prototype. Not exactly as pretty as I had hoped that it would be, but as you're going to see, it is indeed fully functional. So now, oh yeah, looks like me from the past just noticed that something was plugged in wrong. I think that is like the 3 volt and ground cable from the analog sensor, from the breath sensor. But whatever, I corrected it, and then some days later I went on to change the whole thing anyway. So as you can see, the second prototype is not necessarily a big improvement on the first one, but it is at least now in fully enclosed shape and made out of a more durable material than the other one. Anyway, let's plug it in and see how it works. But first, of course, I have a couple of comments about stuff that me from the past didn't know at the time or just plain missed. First of all, of course, the same stuff about thumbtacks applies here as in the previous build. Same goes for the breath sensor. all of my breath sensor designs are really interchangeable. So if you see one you like in one of the other tutorials, then you can incorporate it in an ocarina, no problem. Finally, and this is my main point for this specific design, if it can even be called that, since filming this build, I've refined my instrument body making technique a lot. And specifically, I have a series of designs for what I call box ends, which would apply perfectly to this build, keeping all the other materials exactly the same and ending up with a much more sturdy and pleasing final result. The ones I'm talking about are used in one of my designs for the KLIK, as you can see here. That's this 3D printed end piece and this other one up here, which make the construction of boxes very simple, sturdy, and pretty aesthetically pleasing, if I do say so myself. Another idea that you could take from the KLIK is these 3D printed keys here. They would also go very nicely with the ocarina and would work just fine. Go check out that tutorial if you want to see how I use them. And if that hasn't been published yet, then subscribe and stay tuned for when it does come out. There's a link in the description to where you can download these 3D models, as well as the breath sensor and all the other 3D printable models I use for the KLIK instruments. Okay, enough about that. Let's check out how this works, and then we can get on with the third and final build. First, let's calibrate. So yeah, this breath sensor feels a little bit different than the other one. It's a bit more sensitive. This one is the 3D printed one. Extremely responsive, which is nice. That's flutter tonguing. Actually picks that up a little bit. Although, as you will see in other instrument builds, the bottle top breath sensor that I make is even better at that. Very nice. Okay, let's get on with the third and final ocarina build. So this is a little bit different, most of all because the main body of the instrument is 3D printed. So if you want to build this, then you're going to have to print these two pieces here, and they're going to form the main body. We'll get into the details of how exactly they fit together and how it all works throughout this build. But it's pretty obvious. We have these 4 holes here where the keys are going to go. Then we have some cutouts on the inside where the electronics will fit, and which gives us access to the breath sensor. And these two pieces are actually screwed together with some little machine screws, M3 machine screws, which thread directly into the plastic of the second piece. We also have these little disc shapes here, which are basically the equivalent of the thumbtack from the other two builds. And so we're going to put some conductive material and some tape on top of those, and then the difference is that in this case they fit inside these little holes on the main instrument body, and that's going to cover up the ugly folded back edge that you saw on the previous build. So the rest of the materials are basically what we had in the previous build, so some cables, breath sensor, sensor modules. You can see that we have a green breath sensor in here, and that's actually not going to work. It turns out to reflect too much of the light inside from the CNY70 sensor, and so I actually end up changing this out for a black one, just like in the other build. And the sensor that comes with the kit when you buy it is also this one, but in black. So just ignore the green color for now. As you can see, everything is exactly the same as in the previous build. It all fits together just the same. Balloon inside, plastic disc made from food grade plastic, and the cables plug in just like that. And then inside the main body of the instrument we have a cutout for the mouthpiece and a little channel for the tube. But as you can see in the channel, there's a little cutout notch which is going to fit the rolled back part of the balloon. So we need to just roll that back so that it fits exactly inside that notch, just like that. And that will allow us to close the two pieces together once we're ready for that. Next we need the cables for the breath sensor. They have a little interior channel here that they need to fit through, and we need to fit them through one by one. because they won't all fit through at the same time. So that's a bit of a hassle as well. I was working a lot on making this ocarina body as small as possible, and it kind of ended up making the assembly a little bit more tricky, but it works. So as you can see here, we plug in those cables and then the breath sensor fits into its cutout. The silicone tube goes into its place, and then the other half of the body will fit on top, just like that. Okay, but we're not done yet. There's still a lot of stuff to do. Also, yeah, it's not really closing very well there on one side. We'll have a look at that a little bit later. There's also a cutout for the calibration button. And so that's right there. And we're going to insert the calibration button into one half of the instrument body and then glue it into place there. So that when we fit the other half on top, that's just going to help to keep it in place. Again, just a few drops of hot glue on there. And then we just hold that in place until it sets. Make sure that you don't get any hot glue in between where the two pieces of the main body will touch each other, because of course that won't permit closing the body up properly. So there you go, the button is glued into place, and we're still able to close up the instrument just fine. And you can see the button peeking out there at the bottom, just far enough out to be able to press it, so that should work nicely. Time to get to work on the keys. Now, there's a little bit more work to these keys than to the previous ones, because we need to make the conductive surface, whereas the thumbtacks are actually conductive in themselves. So we're just going to put some copper tape on top of this disc here. The copper tape comes included in the kit, and then we're going to fold it down over the edges, just like that. We leave one corner sticking out here, which is going to be the tab that we're going to solder to in a second. So let's get our soldering iron out. So we have a little cable here where I cut off the end connector, and I just stripped the end of the cable, and now I'm putting a little bit of solder onto that. So now we need to solder, put a bit of solder also on the copper tape. Very easy, just like that. It's super easy to solder to this tape here. We just heat up the two pieces for a couple of seconds, and we're done. You can see they're stuck together really well, so that's perfect. Now we need to put on the dielectric layer, and just like before, we're using this standard electrical tape here. Again, we're cutting off square pieces and then fitting those on top, and then just cutting off a little bit of surplus material so that we don't have too much stuff going on in there. We do need to leave a little bit of overhang here because we still want to fold it down like this over the edges. So that's really ugly at first, but of course we're going to put it inside one of these holes here. And it's going to go up flush against that inside edge, and so from the outside we won't be able to see the folded up bits at all, and it's going to make this a very nice looking little key surface. Okay, so not super nice looking, but definitely much nicer looking than the previous ones. Actually, I think this one turned out so ugly that I eventually go back and fix it. We'll have a look at the end of the video to see if that still looks that bad. Anyway, put a couple of drops of hot glue on the back just to keep everything in place, and then we can move on to the next one and finish the rest of them just the same as the first. So once the keys are done, we're ready to start connecting the microcontroller. Now the microcontroller fits into the piece that has the breath sensor on it also, so we'll start with the breath sensor cables that we just passed through that channel just a second ago. Let's see if everything fits together. Yeah, end up rotating this a little bit, just trying to figure out exactly how to fit it in there with the cables. Eventually I figure it out, and then of course now we need to connect the cables from the keys. And once again, I'm marking off key number 1, 2, 3, and 4, and that's going to tell me exactly where to plug each one in. So let's just have another look at that graphic from before so that I can show you exactly where everything plugs in. Okay, so now that everything's connected, we need to fit everything inside here and still be able to close it up. So let's try to put in the USB cable. That has a little cutout there, so that works nicely. And then let's try to close up the two halves. So sometimes the cables from the keys will get underneath, in between the pieces on the outside, so just push them back into the inside hollow space there and then squeeze everything together. Then we can put in those little M3 screws and just clamp everything together. And now we just need to finish preparing the breath tube here. We just cut it down to size, more or less. And then of course we need to have a little hole in it for the pressure to escape through, just the same as in the previous two builds. And that's that. And so that's the third build complete. Now if we prepared to the previous two ones, then this is definitely a step up, both in sturdiness, aesthetics, although I have to admit that the functionality is exactly the same. Nothing has improved there. But anyway, let's plug it in and see how it works. But first, again, let me just make a quick comment. I'll keep it really short this time because I already covered everything to do with the functional parts for the previous build. But I do have a few words about this 3D printed body. The version featured in this video was cool, but a bit on the small side. Specifically, it was very hard to fit everything inside it, and closing it up was a bit of a nightmare, to be honest. So I made a new and improved version with a bit more space and a raised edge around the rim here, which makes closing it up a bit easier to deal with. This is the model that can currently be downloaded from the link in the description. I'm still not 100% happy with it, so expect more updates in the future. Okay, let's try it out and see how it works. Okay, so let's see how that goes. First, we calibrate. Okay, that's the same kind of breath sensor. It feels very much the same, but I think I want to blow a little harder to calibrate it to a harder breath. Let's try that again. Okay, that's better, but I'm getting a little bored with this sound now. Let's see if we can find something else. Nice. So let's just try the scale again and see if it works. Just like the other two, exactly the same. And there you go. As you can see, that final one works exactly the same as the other two. It's really exactly the same instrument, just with a different exterior with different materials. The KLIK Ocarina is arguably the simplest instrument in the entire collection. It's a great place to start, especially if you want to try to make your first MIDI wind instrument and get familiar with the concepts involved. With only 4 keys and no other options, you're unlikely to get lost in cables and connections. Next step up the MIDI wind instrument ladder would be the KLIK Recorder with its 8 keys. And if that's not enough for you, then you might want to try a hand at the KLIKsaphone, which is a sort of super-powered saxophone emulator with 13 keys, more than 6 octaves of range, and extra optional features like pitch bend. Both of those can also be made using the KontinuumLAB Instrument Kit. But still, the Ocarina is, as you can see, a fully functional instrument with good breath sensitivity and a full chromatic scale over 2 octaves. And don't forget, all of the instruments in the KontinuumLAB Instrument Kit also have a companion video, which is published shortly after the tutorials. The companion videos go into more detail about how to calibrate and play the instruments, as well as the different options and settings. The companion video for the Ocarina is quite short because its options are very limited. And that's all for this KontinuumLAB MIDI instrument tutorial. Go check out the other build videos right here on the channel, and I'll see you in the Kontinuum.